honestly, I won't judge. So let's start with Boolean algebra. Just like yesterday, actually, I'm not going to do a lot of the explaining. I'm going to do a lot more of just doing the work to show you guys, to make sure you guys get everything. We will be ending at 10 today. So until then, I will try my best to do everything. So the first question asks, how many order triples make the following Boolean expression true? Emphasis on the keyword true. So and we're given this big equation. And since it's pretty big, let's simplify it. So the original equation is C times if you look at these, you'll probably see something in common. All right, so let's simplify the big knot first. If it's a bit messy, I do apologize. I'm not the neatest person, so you're just kind of have to deal with it, which I say to you, sorry. So actually, we see it simplifies to not A plus not B times C. So let's just distribute that for the sake of sanity. C. All right. Now let's distribute this out. We have a lot, right? So we're just going to go from left to right one by one. We're going to distribute, then simplify, distribute, then simplifies, and repeat, repeat, and repeat. So it's going to be not A, B, C, plus not C. This is going to cancel out. It's going to be, this is going to cancel out as well, technically. So we're going to keep a C here. And then let's move on to the next one. Next part. It's not A, not B plus C times A, B, not C times A, B plus C. And then once again, let's distribute and then simplify. You know, if you distribute it out and then simplify this. And then once again, if you distribute and simplify, you should get. And we're trying to make this false, right? I mean, we're trying to make this true. However, we have a little problem. Let's distribute this. If I do not AC times AB, that's 0. And if I do not AC plus not C, that's also going to be 0. So that's just equal to 0. However, we're trying to find order triples that make it true, right? However, it's 0. So no matter what the order triple is, it's always going to be false. So if we go, I just got a question. It says, how did I get not AC in the first parentheses on the third line? Give me a second. 1, 2, 3. How did I get this? Are you asking the one I just underlined, is that the one? Yes, okay. How I got that. So if you were to distribute everything, not AC and whatnot, what'll happen once distributed? I'll write out the long form of that. The long before I simplify it would happen not A B C plus not A B times B not C not plus C multiply that, it'll be not A C plus B not plus C not C. And if you're wondering why I did this, well, if you were to do the math and actually like try to work it out, this is what you're gonna get. I'm sorry, like it's kind of confusing, like why I got it, but if like you were to just distribute it, it just kind of works out that way. So that's the best explanation I can give because honestly, when I was doing it, I kind of didn't understand why that happened, but it's like, oh, okay. Hello, hello, hello. You're right, give me a second, please. Can you hear me though? Before I move on, can you guys hear me? Yes. All right. Because someone told me my mic was going in and out. So yeah, my internet isn't that good today. So like, please tell me immediately if something goes wrong. I know it when you distribute it, it doesn't work out, but technically this is supposed to be connected. Um, yeah, well, I'm sorry on this one, it's kind of confusing, but if you were to do out the math, it does work out to this. Even if I didn't distribute that, it does work out the same way. So yeah, it'll just be 0 in this case. I'm sorry, Julie, I can't really give you a satisfying answer because like even like I did it, but even then I'm not like 100% exactly 100% sure why it works like that. That's not very satisfying for you, but that is on me. Um, let's go to the second question. One once again, I apologize that I can't really explain that well. I'm not like the best person at theory. So yeah, let's move on to the next one, which is going to be the bit string flicking. We see here, this one is actually not that, it's not going to be all that complicated because we're running the what is it called, the A B C D E kind of thing. So it's LC1. And we see here is X, and which is the same thing. So it's going to be RS2 A B C D E is equal to 0, 0, 1, 1, 0, 1. And then we're going to do LC1 as stated, and it's going to be C E A. Wait, let me just read the question real quick. It's a big 6-bit string. This is why I say read the question carefully. I forgot to do that. I just assumed it. Put an F here because it is 6-bit string, not just simply a 5-bit. Don't make these kind of stupid mistakes that I do. And if you just and then you're supposed to simplify this. 0, 0, 1, 0, 1, 0, B, C, D, E, F, A, or 0, 0, A, B, C, D, 0, 0, 1, 1, 0, 0, A, B, C, D, E, F. In this case, B and E have to be. Hello? Hey guys, can you hear me? Hello? Okay, yeah, sorry. Zoom just told me my internet wasn't working, so I just wanted to make sure. We see here that D and A equal 1. And since this is an AND, which is multiplication, both of them have to be 1. B and E also have to be 1 because they add up to what is it called? A 1. So B and E. And we see here at last A and D match up, and we see A and D are already 1, so it doesn't matter. So C and F don't really, C doesn't matter what happens. Well, here's the interesting thing. C has to be 0. If C is 0, F doesn't matter. However, if C is 1, F has to be 0 because in this case, if it's 1 here, to be 0 here for it to be a 0 down here. So we have 3 possible combinations, which is going to be answer choice B. All right, any questions? This one was pretty straightforward. This one kind of showed that we have to be very careful. Yeah. Also, Julia, I will, if I do find out why number 1 is like that, I'll DM you personally on what's it called? This I'll actually put in the group chat for everyone to see. So it's like basically so everyone knows what's going on. And now let's move on to recursive functions. Recursive functions, like I said before, are traps set for you. So we've seen these square brackets tons of times, so I don't think I really need to like go into depth of how they work. So f of 3 times thing is going to be the second one because x times y is less than 0. It's going to be f of 2 comma 2 minus 1. So -1. So you might be asking, why am I doing negative 1? Well, if I do y divided by x, it's going to be -3. And I said the smallest, the greatest integer smaller than x. Let's say I put 0. Is that less than -1/3? No, in fact, it's greater. So we have to find the integer that's less than -1/3. That's the biggest. So it's going to have to be equal to -1. So that's henceforth this. F of 2 comma 2 is excuse me, not 2 comma 2. 1 comma 2, and f of 1 comma 2 is going to be f of 2, f of 1 plus 2, and f of 2 comma 1 is going to be 3 comma 0 plus 2, f of 3 comma 0 is equal to f of 1 comma 3 plus not plus 0, so there's nothing there matter. F of 1 comma 3 to f of 2 comma 2 plus 3 f of 2 comma 2 is equal to 4. We go up from there 7 7 9 11 and 11 minus 1 is 12, so the answer would be D. Recursive functions, like I said, you just have to be careful and you should be smooth sailing. All right, next question. How many ordered quadruples make the following circuit false? Now, quadruple just means 4 things, but this is quite a long one, isn't it? So I'm using this, I'm just going to write the basic equation. I'm going to write the big equation down for everyone to see, and then we'll start simplifying. AB, A plus B, C plus D naught, B naught, and it's A plus B times C plus D, and that's AB plus A plus B, and that's A times AB plus A plus B, not plus, it's plus here anyway, so it's going to be A plus B times C plus D plus D not that entire thing. And so let's simplify now. Digital electronics is not one of your biggest enemies. Your biggest enemies are going to be like recursive function, the later on problems and such. So I wouldn't worry too much about what is it called, digital electronics, but just still be careful because it doesn't hurt to be like careful. So I'm going to rewrite the equation that I wrote before. It is going to be, once again, this is not A times E. See? Not that entire thing. You add that to plus C times C. Add that to D not the entire thing. And then if you simplify, I'm gonna simplify and thin the big thing first. I'm gonna get that. It's gonna be AB plus AC. Plus, let's see. And then I'm gonna continue simplifying. Okay. And then let's simplify. And we eliminate these. We have seems there was a mistake along the way. Let me just rewrite the equation from the top in a bit more organized fashion. We're going to simplify that. We're going to use the other method, which seems to reduce the amount of errors significantly, despite me being kind of a klutz. It should be fine. B plus C. D. Not that entire thing, multiply that by D. And then get not A plus B. Oops. Not B plus C plus C plus C plus D times D, and it's not times B. Yep, this makes more sense. Distribute. Let's eliminate the things we can. So we were left with not A plus not B, C plus D. And if you were to use the truth table, being like to find the given numbers to actually plug in and try to see what doesn't work, you'll see that 3-ordered triples will make it false. Like A has to be 1 plus say B is 1, C is 1, and D is 0. That makes everything 0. A always has to be 1 and D always have to be 0. This doesn't matter. So here's your 3 combos. Your answer is going to be B3. Yeah. Okay, any questions? All right, none. Can you guys still hear me? My Zoom keeps on telling me there's connections issues. I just want to make sure I didn't lose all of you right now. Can you guys hear me? Okay, thank you, Ian. Let's move on to the next one, which is prefix infix. You guys can probably read what it says. The and means the smaller, and this dollar sign means the average, and we have to evaluate the following postfix. Doesn't seem too hard, right? All right. Let's try that. Let's give me a second, please. Something's not working. All right. Stupid pen. Anyways, let's do this. 6 and gets the smaller of the two, right? If the and gets the smaller of the two, which one is smaller? If we look at it, it's simply 2. And then we're gonna go first level 4 and 2. We're gonna get the average. That's gonna be 3. 4 plus 1 is 5. 2 to the third power is 8. 3 to the second power is 9. We add that. That's 5. No. That's gonna be 8. It's 25. Nope. Nope. That's 5. 5 minus 8 is -3. And your answer is going to be 3. -3. Prefix, infix, postfix is one of the simpler ones. So you just need to be a bit careful and you should be fine. Don't lose easy points like prefix, infix, postfix. I'm just giving you, after I go over number 6, I just want to go over like different, I'm going to do a quick overview of the different kind of problems. We know what kind of problems are coming out. I just want to go over a view of like basically which one's easiest to hit first and then do the harder ones if we're like, if you guys have trouble managing time. So I'll do number 6 and then I'll do that real quick. So in how many years from now in this case would have been 2019, arranged in this, would the octal representation of that year be the octal digits of 29 arranged in descending order? Express the following answer in base 10. So we're trying to find the first order of business. It says the octal representation of 2019 has to be arranged in a descending order, right? To find that, we need to find 2019 in an octal. The 2019 octal would be 2019. Technically, during the test, you're not allowed to use a calculator, but since we don't have much time, I'm just going to punch it in for the sake of speed. Four and 8, it's going to be 3, it's going to be 7, 3, and 0. So the octal representation of 2019 is 3, 7, 4, 3, 8. And this in descending order would have been 7, 4, 3, 3, base 8. And let's now convert this back into what is it called? Decimal. So 3, 7, 4, 3, 3 in decimal would have been 3, 3, 4 plus 3, 5, 8, 4 plus 256, 24 plus 3 is equal to 3867. And if you're wondering what I just did, it's the same thing as binary. You know how in binary it's 1, 2, 4, 8, yada yada yada. And octal, which is base 8, you go 1, 8, 64, and then 64 times 8, which is whatever I just punched in, 512, and then so on and so forth. So that's what I did to convert to binary. I just took a little shorter route right now. And 3867 minus 2019 is going to be 1848. See, so you might be wondering, shouldn't the answer have been 3867? Well, no, because they asked for the difference from now. So it'd be 3867 minus 2019 because that checks how far it is from now. All right. Little like before I move on, I want to do that little hint thing in the middle. So we see the easiest ones to hit are going to be prefix, infix, postfix, your digital electronics, bit string flicking, and Boolean algebra. Next order of business in this case would be these are the a little bit more complicated ones, would be recursive function takes a long time, so I don't recommend doing that. Computer number systems, data structures, Lisp or graph theory, and FSA. And the last things you want to do is assembly language. What does this program do? And recursive. Recursive, you can technically do second because it doesn't take as long. But the other two, what does this program do? And what is it called? Assembly language, which are very similar in a sense. It's just the format's different. It'll be very hard for you to like do it quickly. So I do recommend doing the other ones, which take a shorter amount of time, and then doing these. That's my little tip. That's like how you finish on time, considering how there's a lot of questions to do. I'm gonna skip 7 for now because I'm assuming you guys do know how to like run while loop and stuff, and I feel like the other ones are a bit more confusing, so I want to go over the more confusing ones first. Yeah, let's start. So this question says, number 7 said, not 7, 8 is, it's asking for the internal path length of the binary search tree, and all the lowercase letters are technically no, all the uppercase are technically lowercase. So let's make the tree. So the question we're given is liberty and prosperity, and we're tasked to find the no, it says here uppercase letters are alphabetically before all lowercase letters, so that means uppercase L is going to be before an A. So I'll show you how that's going to work out. These little niche details will affect your results, so I do recommend reading it. And when you make these trees, like I said, maintain like a constant level, like when it comes to like these different trees. So let's go L, I is greater than B, E, we have a R, T, Y, and we have an A, we have an N, we have a D, we have a P, uppercase P, which is before everything, P, R, O, S, P, there's another P, there's an E, there's another R, That's prosperity. And there's another I here. No, or there's a, yeah, no, yeah, there's an I misspoke. I. And then there's the T. And then there's another Y, which would be less than. So we have to find the internal path length. So what we're gonna do is we're gonna divide this into levels. That's first, second, third, fourth, fifth, sixth, and seventh, and then eighth. So this is gonna be level 1. The first one doesn't count. 2, 3, 4, 5, 6, 7. And what you're going to do from here is you're going to look at how many nodes are there, basically how many letters are there, and then multiply it by the which level it is. So it'll be 1, 4, 12, 24, 26, and 7. So, and if you add that all up of 1 plus 2 plus, no, it's 4 plus 12 plus 24 plus 20 plus 6 plus 7, you should get 74. And your answer choice is going to be D, 74. Let's go to 9, list. List, like before, is important. You got to remember what you're doing. So, okay. Let me write out Y, which is going to be ever so long, annoyingly. A, B, E, A, B, C, D, E, F, G, H. Wait, this whiteboard. 3, F, D, A. And this is your set. And then what we have is a C. We have a D, A, R, D, A, D, D. That's CDR, CDR, CAR, CAR, reverse, CAR, CDR. I just didn't put it in here because it's too long and it would be complicated to look at. So let's do it. CDR means it'll mean the first one. Once again, it'll mean the first one. Then we have we're gonna put this here. It's after we do this, it's and then there's CAR, which means only get the first one. So that would be this entire thing. A, B, C, D, E, F, H. And then from there, CDR, once again, remove the first one. So it'd be parentheses here. And then it says reverse. We're simply going to reverse like this. Like this. And afterwards, CAR, just get the first one, which in this case would still be EF, G, H, E, C, D. Like this, and then it says CAR. No, wait, this is CAR. My bad. And then we're gonna get we're going to get C. We're going to get CAR. I'm sorry for messing up so much today. EFGH. And then we're going to eliminate the first one. In this case, it'll be E, so FGH. And that would be answer choice C. Yeah. Be careful while you're writing. Make sure you keep track of where you are. I'm kind of a mess right now. I do apologize for that. Now let's move on to graph theory. This one, it says ACSL air was just merged with composite air. ACSL air's flights are shown in the directed graph on the left, and composite A airs are on the right. How many more round trips can be taken from A after the merger without landing at the same intermediate state more than once? So this is an interesting thing. So let's do let's do this. All right. We're gonna try our first order here is gonna be try to find all the loops, not loops, the round trips you can get from simply just ACSL air. So in this case, CD, we're only ABCD. So A goes to B and C, B goes to D. Oh wait, A, C, D. C goes to B and D goes to A. So we see A, B, C. So B goes to A, B goes to C, B goes to D, D goes to A, C goes to B, which can't happen, D, A. C goes to B and D, B goes to A and D, A once again. So the available loops are just ACSL, it would be ADA. No, actually, no. What? ABA, ABCDA, ABDA, ACBA, ACBDA, and AD. All right. And then after the merger meaning combining with them, we see that we're gonna add inclusion. B goes to G as well. C goes to G as well, and as well as B, as seen here. F goes to B. G goes to F and nowhere else. F goes to C. C also goes to F. And yeah, that's the new paths that we made because B goes to G. We established that. C and B go to each other. We already established that as well. D goes to not D. That's F goes to C and only C, and G goes to F and only F. So let's make new combos, all right? Let me just erase this. So what we're going to do is basically the same thing as what we just did, just with additional letters. And this one says how many more, right? No, the more it says how many more, but that's just a trick. It's not saying. It says no, the more is not the trick. There has been no, ignore what I just said. I was gonna try to explain, but it sounds a bit wonky, so we're just gonna go with what we have. A goes to B and C. And from B and C, B can go to A, B can go to C, B can go to D, B can go to G, C can go to D, G, F, D just goes to A, G can go to F, which can go to C. I'm going to do this branch first. D can go to A, G can go to F, which can go to C. We can't go to C here. So it ends at F, and F goes to C here again. So it ends. G goes to A, B, G, F, C. C goes to, can go to B, can go to D, can't go to G or F. D goes to A. And C goes to B, D, G, F. D goes to A. B can go to A. B can go to, can't go to C. We can go to D. D can go to A. And D can go to G. We can go to F, but F goes to C, and F can go to C. F, C. And from C, you can go to, can't go to B. We can't go to, we can go to D. And yada yada. You're just gonna have to make the tree. It's long and it's kind. I don't have much space, and it's gonna just confuse you guys more. But it says here. It says here you can't land at the same intermediate city more than once. So if you were to make out the tree and then simplify, you would get A, B, G, F, C, D, A, A, C, G, F, B, A, A, C, F, B, A, A, C, F, B, D, A, A, C, G, F, B, D, A, which is going to be answer choice 5, and which is B. Yeah. All right. We have 5 minutes remaining, so this is going to be the last question. We're going to do Fsa regular expressions. So it has to start with a number, or it doesn't have to because of the star. So let's all of them work, that means. So, and then the next, after the numbers, there has to be a capital letter, or it doesn't have to be because of the star. But let's see. Works. All of them work. A through Z, lowercase. You can have it or you don't need to have it. There we go. All of them, let's see, do work. And then we're going to have one of these special symbols after the letters. So let's look through it. Does the first one have it? Yeah, because it works because there's the period. There's an at. There's a slash that works. That works. The at. There's an and here. And this dot here. So all of them work so far. And now there cannot be AD, and there has to be combination of E and T's at the end. Wait, let's run this again. I made a little mistake. I was just doing B doesn't work actually if we look at it, because there's a capital letter after the lowercase letters, so B doesn't work. Let's see if I missed anything else. We see the last letters cannot be D, E, or T. And so let's see which ones have D, E, or T after the symbol. There's that one. After the symbol, there's nothing. After the symbol, there isn't anything. So the ones that work are A, C, E, F, which is going to be your answer choice, D. Yeah. These stars mean there can be there, but they also don't need to be there. And when it means doesn't need to be there, nothing is there. That means 0, because star means 0 through infinity. So be careful of the stars. That's really, really important. Yeah. We have 2 minutes left, and we only have the 2 problems that take more than 2 minutes. So I'm gonna ask you guys, do you guys have any questions? Sure.